Hello, in this video I'm going to work on a few examples where we are given a linear equation and a quadratic equation, and we are asked to find where they intersect, so where the line intersects with the curve basically. And so it could be a parabola. Intersection could look something like this, could be a circle even, intersection be something like that, or even if they intersect at all, because they may not intersect. And so, for example, for example, we're given x plus y equals 11 and xy equals 30. So the first thing one can do here, and of course we're going to have to use the method of substitution. To solve, we're going to set up a system of equations or solve simultaneously, and we're going to do so by using the substitution method. And so in this case, for equation 1, we have x plus y equals 11. Now it's really easy, we can isolate one of the variables. So we can either have y equals 11 minus x or x equals 11 minus y. I'll just go with x equals 11 minus y, and then I will solve for y first, because what I'm going to do is substitute x equals 11 minus y into equation 2. This is equation 1, that's equation 2. In that case, we have y times 11 minus y equals 30. And then we're just going to use the distributive property, and so we have 11y minus y squared equals 30. And now I'm just going to rearrange this by adding y squared to both sides and subtracting 11y to both sides, just to make it a little bit more neat to look at. So we're going to have y squared minus 11y plus 30 equals 0. And now we've got a fairly healthy quadratic equation, which we can solve by way of factorization, because we need to find the value for y. Be very simple to factorize this. And so AC, A is 1, C is 30, so AC is going to equal 30. So we need to find what multiplies to 30 and adds to negative 11. 2 and 15 is not going to work. 3 and 10 is most certainly not going to work, but 5 and 6 will work. So 5 times 6 equals 30, but we need to add to negative 11. And so if we just set both of these to be negative 5 minus 6 is going to give us negative 11, and when we multiply these, we'll get 30. So those are two factors: y squared minus 5y minus 6y plus 30. All that sets equals 0. So from the first pair of terms here, we can just factor out a y. So we end up with y minus 5. Here we can factor out a negative 6, and we're again left with y minus 5, which is where we want to be. And now we can just continue the process of factorization. And so we have y minus 5 or y minus 6. And of course, if we continue on to solve for y, we're going to get y equals 5 and y equals 6. So those are two y values. Now with questions like these, really one just has to carry on with the grunt work, and we need to just basically substitute these y values back into, in this case, equation 1, where we have x equals 11 minus y, to find our corresponding x values. So I will write that over on the right hand side. If I just erase this quickly. So when y equals 5, x is going to equal 11, well, x equals 11 minus y, so 11 minus 5, which is going to give us 6. And so our first set of coordinates is going to be 6 and 5. So that's one point of intersection where this line meets the curve. And now when y equals 6, as we found down here, x is going to equal 11 minus 6, which is 5. And so our second set of coordinates is 5 and 6. And so there you go. That's where the 2 points of intersection. There are 2 points of intersection, and they're precisely at the point where x equals 6 and y equals 5, and x equals 5 and y equals 6. Right, let's do another example, work on something a little bit more difficult and a bit more fun. Say we're given x plus y equals 9, and we are given a circle equation this time, where x squared minus 3xy plus 2y squared equals 0. X squared minus 3xy plus 2y squared equals 0. So again, for equation 1, it's equation 1, that's equation 2. So we need to find where this line meets this circle. Now what we can do is, again, we can subtract y from both sides and have x equals 9 minus y, or we could subtract x from both sides, but I'll just stay with x equals, set it to x equals 9 minus y. And now we're just going to substitute this into equation 2, in which case I'll just continue down right below here. So we'll have 9y squared, because I'm substituting in for x, minus 3y times 9 minus y plus 2y squared equals 0. So there are a few things we need to do here. We need to FOIL this out, the 9 minus y squared, and we can use the distributive property here, and we'll need to identify and collect like terms and simplify and so on. So this is going to be 9 minus y, I'll just write it all out, 9 minus y times 9 minus y minus, and well, 3y times 9, well, 3 times 9 is 27, so it's going to be minus 27y, and negative 3y times negative y is going to be plus 3y squared, and then we have still our 2y squared, so plus 2y squared equals 0. And I'm just going to FOIL this out now. So 9 times 9 is 81, and that's going to be negative 9y. 9 times negative y, negative 9y. Again, we have negative y times 9, that's just negative 9y. And we have negative y times negative y, that's going to be plus y squared. We've still got a negative 27y here, and we can combine two y squared terms. It's going to be plus 5. This is 5y squared, so plus 5y squared. And of course, all that's still set to equal 0. So we can just combine like terms. Start with y squared. We have 2y squared terms, so it's going to be 6 y squared plus 5y squared is 6y squared. And this is negative 9y minus 9y. It's just minus 18y. Negative 18y. So and negative 18y is negative 18 minus 27 is going to be well, 3 would be 30, and then 15, so 45. So it's negative 45y. And now we're just left with our constant, which is plus 81. Right, now we can, yeah, it's not divisible by 6. Can't divide by 2. You can divide by 3 right across this entire equation. And so 6 divided by 3 is going to give us 2y squared. And 45 divided by 3 is going to give us 15y. And 81 divided by 3 is 27. Yep. And so now we should be able to solve this by factorization. Yeah, it should be a little bit more simple. We can factorize this, I think. So 2 times, so we need to find AC. So AC, well, A is 2, C is 27, so 2 times 27 is 54. And so now we need to find what multiplies to 54 and adds to negative 15. So I'm thinking 54 divided by 6 is 9. So 6 times 9 would equal 54. And it would also equal negative 15 if we set both these to equal negative, because negative 6 minus 9 is going to be minus 15. So we've got our two factors. So that was fairly straightforward. So we just rewrite this as 2y squared, and I'll put the 6 on this side. So minus 6y minus 9y plus 27 equals 0. And we just need to carry on with our factorization. So we can factor out a 2y from the first, so 2y, and that's going to leave us with y minus 3. And we can factor out a negative 9 here, and that's going to be y minus 3, which is exactly where we want to be. And so we are going to have y minus 3 or 2y minus 9. And I'll just scroll down a little bit more. And so therefore y equals 3. Of course these are set to equal 0. Or y is going to equal 9 over 2. Okay, and so now we just need to substitute our y values into the very first equation, equation 1, in order to find the corresponding x values, and we will have the exact coordinates of where this line crosses or intersects with this circle. So for the first one, I'll write it up here. When y equals 3, x equals 9 minus y, so it's going to be 9 minus 3, which is pretty simple. It's going to give us 6. So our first set of coordinates, 6 and 3. And now when y equals 9 over 2, x is going to equal 9 minus 9 over 2, and so we're just going to multiply this 9 by 2, so it's going to be 18 over 2, which is of course going to just leave us with, well, 18 minus 9 is just 9, so it's just going to we're going to end up with 9 minus 2, which could also be written as 4 and 1/2 if you wanted. Just leave that at 9 minus 9 over 2. Sorry, and so therefore our second set is going to be 9 over 2 and 9 over 2.